Finally, we're going to end this unit by talking about the blood-brain barrier. Now, when I first heard this term, I misunderstood it as there being some kind of wall in your brain that filtered the blood before it got to your brain, but it's not a single wall. What it is it's actually a property of the capillaries. Remember those tiny blood vessels that we saw the astrocytes pulling nourishment from and kind of putting waste back into? Capillaries in most of your body are leaky on purpose. The endothelial cells that line them are loosely spaced so that oxygen and carbon dioxide can be exchanged, and so that many other nutrients and waste materials can travel through them easily so that you're able to nourish and take care of all of the tissues in your body. In your central nervous system, however, we have those capillaries are kind of constructed so that their endothelial cells are more tightly packed. The bricks are kind of mortared together more strongly. A few substances can filter through these tightly packed endothelial cells passively without exchanging energy. Things like oxygen and carbon dioxide exchange can still happen. Some fat soluble vitamins get through in that way as well, but some things don't get through at all. The molecules are just too big, or we need a lot of energy to move them across the membrane. So most of the nutrients that get through are glucose, just sugar. It's the primary fuel for your brain cells. Now, this is the case because it keeps out pathogens. So, like vitamins and stuff, some of them can be big molecules that don't get through the blood-brain barrier. Drugs can be big molecules that don't get through the blood-brain barrier. That's kind of a problem. But it's this way because it keeps out pathogens. Viruses and bacteria can be big molecules, big structures that are not going to make it through. The reason we need to be super sure that infections don't get into the brain is because the immune system works differently in the brain than in the rest of the body. In the rest of your body, when your cells get infected by a bacterium or a virus, your body's immune cells can just kill your infected cell. It sacrifices your infected, like zombie body cells. However, in the brain, you don't refresh and create new cells all the time. You do in the rest of your body. Not a big deal to have to sacrifice some skin cells because they just take like a couple days to make more. You can replace all of them. And even bone tissue and stuff like that eventually replaces itself, albeit pretty slowly. In the brain, you're born with most of the cells you're going to have. There's a very few teeny tiny baby neurons that get made in your hippocampus, but pretty much nowhere else. And we don't even know how common that is in your hippocampus. So we can't afford in the brain to just kill any zombie cell that gets infected. And so your immune system does not work that way in the brain. It has to kind of try to quarantine those cells and treat them a lot differently, but the immune system is actually less effective in the brain. In a state of nature, before we had drugs to treat these kinds of things, you were kind of just screwed by the time an infection got to your brain if it got through your blood-brain barrier. Now, Jared Younger, in those videos where he talks about microglia and neuroinflammation and COVID-19, he talks some about the blood-brain barrier and the challenges of how your immune system works in the brain, so I highly encourage you to watch those. And for the rest of this week, make sure that you read all of Chapter 1 in your textbook, again, that you complete Collaborative Quiz 3, where you need to make your initial post by Wednesday and then reply by Sunday night. You need to also complete your Prep Guide 3, due Sunday night, and remember that this one is about the results section only, not the methods or the purpose or the discussion or any of that, just the results. That's a dense section that's difficult to read, so please let me know if you have any questions along the way and just kind of do your best and I'll give you some feedback. Make sure to take a look at any feedback you've already received on Prep Guides 1 or 2 before you write, though. And that's all, folks. I hope you have a good week. See you next week.